I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. So I hope in this part of mechanics you have understood the concepts about moments and you must be enjoying the practice test questions which we have shared with you. Now these questions have appeared in past test papers and therefore their solution will make a lot of sense. I'd like you to read the question, answer, and then look into my suggestions. Question number 3 here is a non uniform rod AB of length 2A is suspended by three vertical strings attached to AC and B, where C is the midpoint of AB. The tension in these three strings are in the ratio of 3 is to 2 is to 1, respectively. Find the distance of A to the center of the mass of the rod. Very interesting question. We have non-uniform rod in this particular case, and we are providing you with three strings having ratios as 3 is to 2 is to 1. So once again, let's first sketch the diagram and then work on it. So let's say this is the string, this is the rod. So non-uniform means that the mass will not be right in the center. Rod is a rigid body, as you know, which has only one dimension, length. The width or the thickness can be neglected as it is too small as compared with the length. So that is how we actually define a rod. Important thing to understand. So the total length is 2A is suspended by vertical strings attached to A, C, and B. So let's make these vertical strings at A, C, and B. So this is at A, this is at B, and right in the center at C. Since the length is 2A, we'll keep A here and A there, and we have these 3 points which are ACB for us, C being in the center, correct? Now, since it is non-uniform, we will have to use the mass focused not in the center, somewhere else. And the question here is, find the distance of A to the center of the mass of the rod. So let us say that the center is somewhere here. Okay, I'm just assuming. I really don't know where it should be. So this distance from the center is what we need to find from A. Let this be X. Is that clear to you? So that becomes the center. Now, the mass in this case is not given to us, so we'll write mg. You can write weight W also, correct? So, a uniform rod AB of length 2A is suspended by three vertical strings attached to ACB, where C is the midpoint of AB. So, that part is clearly drawn here. The tension in these three strings are in the ratio of 3 is to 2 is to 1. So, let's write this as 3T, 2T, and T. Find the distance of A to the center of the mass of the rod. Clear. So this is absolutely clear, right? So we have to find the mass, so it's better to write mg. So we'll find mass. Is that clear to you? So let the mass be m. And then we'll take the value of g as 9.8 meters second square, right? Perfect. So now, from here, as we have solved earlier also in many examples, we'll first look into the vertical forces. Their sum is 0. So the vertical forces is 3t plus t 2t, sorry, and t, right? So let me write 2t plus t should be equal to the mass m times the gravitational force, which gives you the weight. So we have 3 plus 2, 5 plus 1, 6t equals to mg. So that gives us one relation. Now, second thing is we need to look into now the moments. To find the moments, we can choose any point. So moments about, let's say, A. So we'll equate the clockwise moments with counterclockwise moments at A. That's the whole idea. The clockwise moment is because of the weight. So that gives us the clockwise moment. So which is x distance from A. So that is our assumption. So we say let the center be x units. Let the mass of the rod be m x units x from distance A. So we need to find the distance. Find the distance of A to the center of the mass, right? So let this distance be A. So let center of mass be x meters from A. Correct? So we have used that. So we can now write mg times x equals to the counterclockwise moments are because of the tensions, right? So these two provide us the counterclockwise moments. So let's write down those, which are 2t and the distance is a plus t times a, right? So that gives you the equation. Now we can substitute the value of t and find the answer. So we get the equation as mgx is equal to 2t times a and t times 2a. So this is also t times, sorry, 2a, right? So t times the distance is 2a, right? T times 2a. So which is 4a. So we have 4ta, correct? So 2ta plus 2ta is 4ta. So we get the value of 4ta, correct? So mg is basically uh, equals to 6t. So from here we can write what t is, right? So this gives you the value of t as 1/6 of mg. Clear? Now we can put this value here and find the value of x. You get the idea. Or I could also write mg as 60 and solve the question. So let me use this concept. Mg I'll replace with 60 because we need to find x, correct? So this time I'll go with a variation, and that is we are substituting mg as 60. So we get, let me write 60x equals to 4t a. So in this particular case, t and t will cancel, as you can see here, and we are left with 6x equals to 4t. So we have 6x equals to 4a, sorry, right? So in terms of a, we can find what x is, which is 4 over 6a, and that gives you the value of x as 2 over 3a. Is that clear to you? So we have our answer, and that is the distance is 2 over 3a. So 2/3 of a, right? That is what it is. So we'll assume that the units are in meters, right? Now that is how we are going to solve this particular question. So in the units of A, it's a ratio, right? So I hope it is absolutely clear. In case you still have any doubts, you can always send an email on the address given here or write comments at the end of the video. Feel free to participate and share more questions. Thanks for your time and all the best.